This is the lab lecture video for the procedure of the determination of the dissociation constant of a weak acid. Check out the video about the calculations and the background theory for information on those. You'll also need to watch the video about using the pH meter, and knowing that watching the video and using the pH meter, when you get in the lab, your pH meter will have a set of instructions next to it, because we have multiple different brands and types of pH meters. So you will have to read instructions once you get to the lab on the exact buttons to push for your version of the pH meter. So part A of the lab is how to calibrate the pH meter. And again, that's what you're going to be following the instructions from the information that's given to you when you get into lab, as well as this information is covered in the pH meter video on how to handle the pH meter probe and the correct way to just deal with the pH meter in general. So for part B, which is the rest of the lab, you're going to be doing 3 titrations. Okay, but these titrations will be using a pH meter instead of an indicator, so there will be no color change. We will know when to stop the titration when we see this jump in pH value that's going to come from looking at the pH meter. So to get set up, well, your burette, which you'll be using for the titration, will need to be conditioned and then loaded with sodium hydroxide. So the sodium hydroxide molarity will be given to you. If it is known at the time of the lab, it'll be written on the board. If it is not known at the exact time you do the experiment, it will be emailed to you or sent to you by your instructor when that information is known. So watch the video on how to use a burette to learn how to condition and then load the burette. Now, in that video about how to use a burette, the video tells you you don't have to fill it all the way to 0. You can start and stop. You can fill it to whatever value you want as long as it's within the markings. For this lab, and this lab only, you do have to fill it to exactly 0.00 milliliters because we're going to be adding liquid in multiple amounts, and it's just to make your life easier, you need to have it right at 0.00 milliliters. So you will have to add the liquid until that point. Make sure that the tip of the burette is filled with liquid when you're doing this, and that there are no air bubbles anywhere. If there are air bubbles, you are responsible for removing those before you start the titration. You can use a disposable pipette to to get the sodium hydroxide right at that 0.00 mark. I don't know where I went. It's hidden forever. Or you can just pour it in and then use the stopcock to let the liquid out until the meniscus stops right there. So just like whenever we use a burette, we will use a post and a burette clamp. Now when we put on the burette clamp, the post has to go through the 2 rings. We don't use these sides to attach it to the post. Those aren't sturdy enough for that. Those clamps, the clamps on the left and the right, are for the burette. Okay. So you will have loaded your burette with the sodium hydroxide after you conditioned it. So the solution that we're testing the sodium hydroxide against is an unknown weak acid. You will be given your unknown weak acid. It will have an unknown number. Make sure you record that. So we're going to do 3 trials of this. So you will need 3 beakers. The beakers need to be either 150 milliliter beakers, or if we don't have enough of those, then 250 milliliter beakers. They cannot be smaller than 150. They cannot be larger than 250. 150 is really the best, but we don't always have the exact number that we need. So you're going to want to label your beakers 1, 2, and 3 for trial 1, 2, and 3. The unknown weak acid is already in solution form, so we don't need to measure it out with the solid. It's already in a solution form, which means we have to pipette it accurately into our beakers. And you can do the pipetting for trials 1, 2, and 3 all at once. You need to accurately add 25 milliliters of the unknown acid. So you'll be using a 25 milliliter volumetric pipette. Now, be very careful with these buddies. The bulb part right here, the glass is very thin, so it's easy for them to break. They're also super good at rolling. So if you set them on the counter, they're just going to roll right off to the floor. So make sure that you're really careful with them. I would suggest pipetting all 3 trials at once, so then that 25 milliliter pipette can be put away in the appropriately labeled container for our lab tech or lab coordinator to wash it. You're not responsible for washing it. Now, we do have to condition this volumetric pipette just like we would any other volumetric pipette. When I use the 25 milliliter pipette, it takes me more than 1 bulb full of air. So like when we're using our pipette, I submerge it in the liquid in the beaker, compress the bulb, release the bulb until the liquid moves up. For me, the liquid gets to about here, and then I'm not done yet. I need another bulb full of air. So if that happens, your bulb has stopped pulling the liquid up, but the liquid's not high enough. Just put your finger on top, compress the bulb again, and then do it a second time. So just like always, you're going to fill it above the line, and then when you condition, you're just going to let it all drain out. And then when you go to accurately transfer it, you will use your bulb to get the level of liquid above the line, and then use your finger to let the line fall to right at that 1 mark. And then you'll carefully transfer that 25.00 milliliters of liquid into beaker number 1. And then you'll repeat that for beaker number 2 and then beaker number 3. We are not adding any deionized water to this. It's already a solution. It's already been mixed. So we don't have to degas any water, boil any water. It's transfer the liquid into the beaker. Now, since we're doing a titration, we will need a stir bar and a stir plate. So the stir bar, we place on, already on, got excited there. You'll need to turn on the stir plate, but you will have to get all this set up very carefully. So we're going to need the solution with the weak acid with the stir bar stirring. And we're going to have to move the stir plate with the beaker till it's underneath the burette, so the tip of the burette's just inside of the beaker. But the other thing that has to happen is our pH meter has to be submerged into the liquid as well. So you will follow the instructions on how to correctly rinse and use the pH meter. You're going to remove it from the potassium chloride solution that it starts in. Rinse it with DI water over the waste beaker. Use a chem wipe. Dry it. And then you will need to get it submerged in the liquid. So the glass bead is submerged in the weak acid. So what we have here is we've got a lot of stuff going on. We've got a stir bar spinning, and that stir bar cannot be running into anything. You don't let it hit the sides of the beaker. Don't let it hit the pH meter. So you have your pH meter submerged in there. You're also going to have your burette that's able to add liquid, and nothing is blocking that. So you're going to have to kind of find the sweet spot for all of these to figure out how to get this arranged. It's totally possible. I'm using the 150 milliliter beaker, which is the smaller of the two beakers, and I got it arranged. If you're using a 250 milliliter beaker, you have a little bit more space. Okay, so you'll get this all arranged. Again, your burette will be filled, so that way the level of sodium hydroxide is right at the 0.00 mark. And then we're ready to start our titration. So the data table for this, on page 73, there's data table for 3 trials. We're doing trial 1 right now. So you're going to be recording the pH value from your pH meter every time we add a certain amount of sodium hydroxide. So the 2 things we're recording are the milliliters of sodium hydroxide and the pH. So your first entry into the milliliters of sodium hydroxide for trial 1 is going to be 0.00 because our burette says 0.00. And then you're going to record the pH right next to it once this whole setup is there. Now next, you're going to very carefully release sodium hydroxide from the burette until it's at the 1.00 mark. So you'll use the stopcock, the valve, to open the liquid and then to release it. For me, when I use a burette, if I need to be very careful, I'm taking it off now just to give you guys a better view of this, but when you're using a burette and you need to add it a slow amount, people typically kind of do a sideways thing that lets it come out drip, drip, drip. For me, I always screw this up. So when I go to shut off the burette, even though I know it and I've done it a million times, I always open it up really wide. So I'm trying to stop the burette, but what I do is I open it. So instead, when I need to add small amounts of liquid, there. That's not going to work because I need to use my hand. Okay, so what I'm going to do is I'm going to take the valve on the stopcock and I'm going to do a quick 180-degree turn. And what that does is it lets out a very small amount of liquid. It looks like it's more than a drop, but it's actually not. As long as you do it quickly enough. And then I can do that until I get the level of liquid where I need to be. Just be careful that you don't use all your strength and then pull the tip and the stopcock out of the burette, and that's going to spill sodium hydroxide everywhere, and you get to start over. Plus, we get to clean all that up. Okay, so you're going to use whatever technique feels right to you to add 1 milliliter of sodium hydroxide. Now, let's say you don't stop it right at the 1.00 mark. Maybe you overshoot it a little bit, and it's like 1.22 milliliters. Well, then write that down. Accurately record the volume of sodium hydroxide. Your goal is to get 1.00 milliliters, so do the best that you can. But whatever it is, you're going to write that down. So there we go. Sorry, my computer battery was being weird. So you'll record the pH for that. And then next, you're going to add another 1.00 milliliters to move the value of the burette from 1.00 down to 2.00. In your data table, you'll write down 2.00, and then you'll record the pH value. Now, I will warn you, the pH meters, it's going to take a second from when you add the chemical until it calms down. So just like with balances, the values are going to fluctuate a little bit, and then they're going to get to a steady spot, and then that's going to be the value that you record. So you're going to have to give it a second before you write down your number. So what you're going to do is you're going to keep doing 1 milliliter increments, 0 milliliters, 1, 2, 3, 4, but then accurately recording the level on the burette, and then recording the pH until we get to where the pH stops changing. So that would mean like two pH values that are right next to each other. Well, these pH meters, they're really great, but there is a little bit of error in them. So to be two numbers that are right next to each other, what we're going to say is that they're plus or minus 0.03 away from each other. So the pH value from one measurement to the one right after it. If the pH value only changed by 0.03 or less, you have reached the end of your titration. Okay? So you're just going to keep doing 1 milliliter increments until that happens. Every unknown is going to be different, so I can't tell you exactly how many milliliters this will be. It's going to depend on what chemical you have, what your unknown number is, what its concentration, all kinds of things. So that's going to be trial 1. When you're finished, you're going to take your burette, fill it back up to 0.00 with sodium hydroxide to get prepared for trial 2. Get yourself your trial 2 beaker and get ready to go. So you'll have to remove your stir bar, because you'll only have one stir bar since you'll have to check that out from your instructor. One stir bar, well, it's on the stir plate, of course it will not behave, and remove it with the magnet stick, put it in beaker number 2, and get ready to start again. So for trial 2, we're going to start the same way. Sorry, I'm just putting the pH meter back in the solution so it doesn't get dry. We're going to start the same way with the level at 0.00. You're going to write down for trial 2 milliliters of sodium hydroxide, 0.00 milliliters, and then you'll record the pH. And then you're going to start again, add 1 milliliter, so it's 1 milliliter increments. And that's how we're going to start. Well, in trial 1, our equivalence point, which our end point, if we were using an indicator, would have been when the color changed, like when the solution changed color. So our solution in trial 1 did not change color. But at some point, you are going to have 2 data values where the pH jumped significantly by not like 0.2 or something, but by 4 or 5 or 6 pH values. So between those 2 measurements. So I'm going to make up numbers. I don't know what yours are actually going to be, so don't expect yours to match this. But let's say at 21.00 milliliters, your pH value was 4.3. Okay, and 22.00 milliliters, so a difference of 1 milliliter, just one difference, went from 4 points whatever to 9.6. So it jumped by 5 pH units. You're going to have something like that. We're going to have a big jump. So mine in my pretend world was between 21 and 22 milliliters. So in trial 2, you're starting over, filling it up to the top, and do 1 milliliter, write it down, 2 milliliters, write it down, 3 milliliters, write it down, and continue until you get close to where your big jump happened. We're really interested. We want to know where exactly that big jump occurred. So I'm pretending again that my big jump happened between 21 and 22 milliliters. Okay. So what you're going to do is add 1 milliliter increments until you get 1 milliliter before your big jump. So my big jump was between 21 and 22. So 1 milliliter before that would be at 20. Okay, so I would add 1 milliliter increments until I get to 20 milliliters. Once I get to 20 milliliters, instead of adding 1 milliliter increments, I'm trying to zoom in. I want to know exactly where this big jump happened. So I'm going to start doing 0.1 milliliter increments. Yep, you heard me, 0.1. So that's going to be like bloop, or maybe bloop, bloop. And it doesn't make that sound, but you get what's happening. You're going to add very small amounts. And you're going to continue to do that and writing down the pH every time until you get to the end of your equivalence point. So, trial 1, my pretend numbers were between 21 milliliters and 22 milliliters. So I would do 0.1 milliliter increments, starting at 20 milliliters and going to 22 milliliters. Once I get to 22 milliliters, or whatever the end of your equivalence point is, then you go back to ones. Then you'll go to 23, then 24, then 25. And you'll continue the titration, not stopping until you have two values right next to each other in the pH column, which means that a pH value is plus or minus 0.03 from its next pH value. If you have questions about this while you're in the lab, absolutely ask your instructor. If you want confirmation for if your range that you're going to do your 0.1 milliliter increments, like, it's good to have that double checked. An important thing here, do not jump straight from 0 to your 0.1s. You still have to do 1 milliliter increments until you get to that equivalence point range, and then you'll do 0.1 milliliter increments, and then you'll go back to 1 milliliter increments. If you just skip straight down to the equivalence point, you're going to be a super duper sad panda, because you're going to need data in that in-between spot. That's actually some of the most, we have two important numbers. One of them is the equivalence point, where the big jump happens, and the second one is this half equivalence point, which happens between 0 and your equivalence point. So don't jump down. You're not saving yourself time. You're screwing yourself over. So in trial 2, within that 0.1 milliliter range, you will see your biggest jump within that. Now, it's not going to be as dramatic because we're not adding 1 milliliter, we're adding 0.1. But the biggest jump within that small range is going to be where your equivalence point happens in trial 2. So in trial 1, your equivalence point is between two numbers, right? Like in my pretend world, it was between 21 milliliters and 22 milliliters. So I would say that my equivalence point was at 22. It's at the end number. So for trial 2, you're going to have numbers closer together. Like maybe it's 21.30 and 21.40 were my biggest jumps. So then my equivalence point would be 21.40. Now trial 3, once you're finished with trial 2, you'll take out your stir bar, fill up your burette, start it over again. You're pretty much going to repeat what you did in trial 2 in trial 3. Now, depending on if you really did learn something about where your equivalence point was, you might be able to narrow that 2 milliliter range of the 0.1 milliliter increments down to 1 milliliter range. I would suggest talking to your instructor before doing that, just to make sure. And then at the end of trial 3, you've collected all of your data. At that point, we're ready to clean up. So you will need to rinse off your pH probe, put it back in potassium chloride. You will return your stir bar to your instructor where you checked it out. You will, put away everything. The burette needs to be drained completely, so that way the sodium hydroxide is out of it, and then the burette will be placed in the labeled designated container for that. Now, all your solutions at this point, you're going to have, whatever acid you had from conditioning your pipette, your solution from trial 1, trial 2, trial 3, and your any extra sodium hydroxide that you had. That all needs to be neutralized before it gets poured down the drain. There is no waste container for this lab, but those solutions cannot just go down the drain on their own. You can have one giant waste container. That's not a problem. So you can get like a 1 liter beaker and put that 1 liter beaker, mix all your all your solutions in there, and then you will have to neutralize it to a pH of 6, 7, 8, or 9, depending on what you're doing, or depending just any of those values, and then it gets dumped down the drain, and then you can wash your glassware like normal. The two pieces of glassware you are not washing are the 25 milliliter pipette and the burette. Those have to be placed in special containers. When you're preparing for this lab, when your estimated volume of sodium hydroxide, you don't really know how much sodium hydroxide you're going to need. And I can't even tell you because it's going to depend on what your unknown number is. So just to be safe, assume that you need 50 milliliters of sodium hydroxide for each trial. That would be worst case scenario if it took the entire burette full to get to that where the pH value stopped changing. So when you're preparing for the lab, I would assume 50 milliliters of sodium hydroxide for each trial, knowing in real life, hopefully you're not using that much, but that way you've got enough to condition and you're prepared for it. Okay. So again, no waste container. Everything must be neutralized to a pH of 6, 7, 8, or 9. Your waste is going to be at a basic pH. I bet the pH of your waste container starts at 12. So you can use your pH meter while you neutralize. Just put your pH meter in there and then add your acid. You can even use your stir bar to mix it until the pH gets to that 6, 7, 8, or 9. So that's my suggestion on how you're going to neutralize. So I think that's everything I'm supposed to tell you. So yay for the determination of the dissociation constant for the weak acid. Again, watch the other video, the one that goes over calculations and background theory on how to handle that portion.